Valley here. Boy, has he done a lot. The Sword of Excellence recipient, the highest award in the air show industry. Back to the action.
Thank you, Danny Clisham. Take a look, ladies and gentlemen. On the left and directly in front of you now, an airplane, an aircraft, I should say, that just is so radically different in its approach to flight. Widely different types of flying. But Bell Aircraft came up with a concept that melded, if you will, the performance of a helicopter and the performance of an airplane. And they did it with the MV-22 tilt rotor. And it became the MV-22 Osprey that you are seeing approaching from the right. Instead of having a rotor on the top like a helicopter, because a helicopter rotor, because of the design of the aircraft, can only go so fast. It can't get to 300 miles an hour or 350 miles an hour. But the XV-15 tilt rotor can. And you see the tilt rotors with the engines mounted on the ends of the wings, directly connected to what they call the prop rotors. Each of those prop rotors is 38 feet in diameter. The engines that power the XV-15 tilt rotor are Allison/Rolls-Royce turboprop engines that turn those prop rotors with a power of over 6,100 shaft horsepower. It enables the MV-22 to stick to the left. The aircraft will move sideways to the left. And if you look very carefully, you might even be able to see the pitch or the angle of the prop rotors change as it comes to a stop, and then we'll go the other direction. We'll sashay back to the left. It is an amazingly complex aircraft, but with something in the helicopter called retreating blade stall, which limits the top speed that a helicopter can travel, by using this very special tilt rotor technique, the MV-22 can take off and land vertically and then rotate those nacelles, the engine nacelles, forward to go into airplane mode and get speeds of over 325 miles per hour. It can carry up to 24 fully equipped Marine troops. Underneath, from a sling load, it can carry 15,000 pounds. It can get into a combat area, unload troops or a jeep or other equipment, and get out of Dodge very, very rapidly because of its ability to transition from basically what is rotary wing flight to fixed wing flight. These nacelles are rotated by the pilot's left thumb on the power lever in his or her left hand. Pushing the thumb wheel forward will rotate the nacelles down for conventional flight, or pulling back, rotate it up past 90 degrees so it can literally back up. What we're seeing right now is called a pedal turn. By pushing on the right pedal, that in a fixed-wing airplane would be a rudder pedal, in a helicopter, it would normally control the anti-torque rotor or tail rotor on the aircraft. training for Marine Corps pilots and other service pilots takes place at Marine Corps Air Station New River. Now watch, if you will, the nacelles are now being rotated forward. Now, let's say that the pilot is left-handed and goes bowling and messes up his or her thumb. Well, that means the pilot is grounded because they can't move the thumb wheel to go from vertical or short takeoff and vertical landing flight or helicopter mode into conventional airplane mode. The technology also is so advanced that if there is a failure of one of the engines, computers within milliseconds will sense the engine failure